Everybody. What I'm going to show you tonight is going to be pretty brief. It reminds me a little bit of trigonometry when you're asked to verify the trigonometric identities. And this is an algebraic identity, purely an algebraic identity. And I've actually seen people put like a triple equal sign here. Okay, in other words, rather than a single equal sign, put a triple equal sign. And that means it holds for all values in the respective domains. Now, the respective domains are all real numbers, right? There's no square roots of negatives going on or anything like that. So that's kind of the tacit admission in an identity, is that it holds for all values in the domains of each function, the left-hand side and the right-hand side. Now, we're here to verify that this object, the left-hand side is equal to the right-hand side for all real x. Now, a couple of obvious choices are like when you do x equals 7. Let me just write this off to the left here. If you try x equals 7, remember you always try 1 and you try out, the ones that are just the easiest to compute. But if you try x equals 7, see, you're clearly going to get 0 right here, right? Over something, right? Over something that's non-zero, notice. So over something. And then if you put 7 right here, it certainly gives you the cubed root of 8. So you got cubed root of 8 minus 2, and the cubed root of 8 is certainly 2. So this is equal to 0. And also, it doesn't take much work to see. So we verified it for an easy number, 7. And also, it's not too hard to verify for x equals 0. You may want to try that if you want to. For x equals 0, it's also, you can almost see it happening. For x equals 0, right here you would get minus 7, I guess, minus 7 over 7, right? For x equals 0, you get minus 7 over 7. But if you put x equals 0 in over here, you get 1 minus 2, which is negative 1. So you get equals to negative 1. Okay. All right, so we verified it for a couple of choices. X equals 7 gives you the truth. X equals 0 gives you the truth. And that's kind of hard to, that's nowhere near proving the identity. But it turns out there's a pretty straightforward and almost a fairly obvious substitution right here. Notice that the cubed root of x plus 1 appears in 3 different locations right here. And so that it just kind of begs to be substituted. And so if we let u equal to the cube root of x plus 1, if you cube that, you get x plus 1, all right? And of course, if you subtract 8 from that, you get x minus 7. Now that's present right here. You see this x minus 7? X minus 7, well, u cubed minus 8 is actually x minus 7. So you see, we can put that substitution. Our original expression that we're trying to prove to be an identity can get replaced as a function of u, or as an equation in the variable u only. Now, something I didn't write down right here, u squared. And this is just properties of exponents or properties of radicals. That's the index of the radical. There are 3, folks. Then we're going to have x plus 1 quantity squared in here, right? I left that out. Forgot it. Okay, but so you see, that is why you get u squared right here. Okay, you get u squared right here. And then, of course, u itself, this is just a direct substitution. If u is equal to the cubed root of x plus 1, you just have a direct substitution right here. And then the 4 just sticks, no dependency on u. Now, u minus 2 is also a direct substitution. That's just from here to here, down to here, right? Okay, so good. Now, okay, what have we done here? Well, a lot of you probably already recognize this is a pretty well-known identity right here. And by the way, you can check this is true for u equals 0 real quick, right? If you put u equals 0 in here, you get minus 8 over 4 is negative 2, and then negative 2 over here. So this looks like an identity also. And if you rewrite it like, let me write right underneath here. This is very well known. The difference of 2 cubes, u cubed minus 2 cubed, we'll just write it as 8. u cubed minus 8 is equal to u minus 2. And this can be verified just by some very straightforward multiplication. U minus 2. All right, this is definitely an identity that a lot of the kids memorize in college algebra or intermediate algebra. But so you get u squared plus 2u plus 4, right? Now, this definitely holds because it's just multiplication. Again, it looks like some magic's going on here, but notice how you get minus 2u squared twice, and then right here, see u times 2u is plus 2u squared. Minus 2 times u is minus 2u squared. So you see the way this thing is constructed, if you will, leads to a lot of mass cancellation. Everything craps out and you just get the left-hand side, which is u cubed minus 8. Now this holds for all u, a member of the real field. For all u, a member of the real numbers. Now, I guess technically we could stop right here. If this holds for all reals, then this has to hold for all reals because this expression is this. It's an equivalent expression allowing for the substitution. But if you're real picky about this, just this holds for any real number. So if you let x be any real number, let's say x sub 0. So x sub 0. Let me erase that. That's horrible. Okay. Gotta get my pencil working here. Okay, now and again, y'all, we could say done already. I don't think anybody's going to complain, right? But you see, if you do the cubed root, now I'll just let x sub 0 be a arbitrary fixed value of x, right? So that's x sub 0 plus 1. Okay. And you can take on any value, right? You can take on any value. And so if you think of x sub 0 as given, right? Okay, well, the cube root function has range of all real numbers, right? Has domain and range of all real numbers. And so this is going to have a solution because it's whatever the solution is, it'll be contained in the domain of this, right? So again, that probably required no explanation. A lot of people would just sign off and say done. But I think this is nice. Given x sub 0, this equation would have a solution because this has a range or a domain of all real numbers also. All right, folks, I hope that was convincing.